Welcome to the DIY Honda Garage channel. This presentation details the troubleshooting for DTC P16E2, which indicates a PGM-FI-ACG LIN communication error in the Honda CRV models from 2011 to 2016. The PGM-FI system refers to the programmed fuel injection system, crucial for the engine's performance by regulating air and fuel intake. The ACG stands for Alternator Control Generator, which is essential for generating electrical power and charging the battery during vehicle operation. The LIN, or Local Interconnect Network, is a communication protocol that connects various electronic control units, ensuring they can share information effectively. This error code can indicate issues like poor connections or faulty components in the LIN network, necessitating a careful inspection of affected systems and components. The following slides will explore the error, its symptoms, possible causes, and detailed troubleshooting steps to help resolve the issue. DTC P16E2 points to a communication error within the PGM-FI and ACG systems, meaning that the alternator, battery sensor, and the powertrain control module, PCM, can't effectively communicate. The PGM-FI, or Programmed Fuel Injection System, is integral in optimizing fuel delivery for efficient engine operation. The ACG, or Alternator Control Generator, is responsible for converting mechanical energy into electrical energy, supporting vital vehicle functions. Additionally, the battery sensor monitors battery health and sends data to the PCM for optimal charging. The communication happens over the Local Interconnect Network, LIN, which serves as the data transmission line between these components. Proper communication is crucial. If interrupted, it can lead to significant performance issues and potential engine malfunction due to improper fuel management or battery charging. Several underlying issues can lead to the DTC P16E2 error code. Poor connections often occur due to wear, corrosion, or improper installation, disrupting communication between the alternator, battery sensor, and PCM. Loose terminals can also create intermittent connectivity, leading to communication failures. Additionally, a faulty alternator may not correctly manage electrical supply, leading to insufficient power to critical components. Battery sensor malfunctions can misreport battery status, misleading the PCM and creating further issues. Lastly, the PCM may have software issues or hardware failures that directly affect its ability to communicate effectively with the alternator and the battery sensor. Each of these components should be scrutinized to isolate the root cause of the DTC. The symptoms associated with DTC P16E2 can manifest in various ways, affecting overall vehicle performance. Engine performance issues may arise, characterized by erratic idling or erratic acceleration due to improper fuel management. Drivers may observe warning lights on the dashboard, particularly the check engine light, indicating a need for immediate attention. Electrical system malfunctions can also occur, such as dimming lights or malfunctioning accessories, which are directly tied to electrical supply issues. A diminished battery life may also be noted, where the battery does not hold a charge effectively, leading to inconvenient starting problems. These symptoms collectively signal a potential communication failure that requires detailed troubleshooting to identify the underlying cause. In the first troubleshooting step, begin by turning the ignition switch to on, to power the vehicle's systems without starting the engine. Next, utilizing the Honda Diagnostic System, HDS, clear the DTC from the system to reset any temporary errors. This step ensures you start with a clean slate for accurate diagnostics. After clearing the DTC, wait approximately 10 seconds to allow the system to stabilize before checking for any pending or confirmed DTCs again using the HDS. If DTC P16E2 is still indicated, it confirms that a failure is present in the communication system. If it doesn't show up, it may signal an intermittent failure that could be related to poor connections or loose terminals in the circuit. For Step 2, once again, check for any pending or confirmed DTCs with the HDS. This ensures you're aware of the full scope of issues affecting the vehicle. Specifically, look for DTC P16E2, which indicates a communication error related to the battery sensor. If this code is present, it's critical as it suggests further examination of the LIN communication for the battery sensor circuit. If DTC P16E2 does appear, proceed to Step 3 to locate the potential failure area associated with the battery sensor and LIN circuit. If not, move to Step 7 to continue troubleshooting, as it redirects us towards other potential issues that may be present. In troubleshooting Step 3, start by turning the ignition switch to the lock 0 position to ensure all systems are powered down safely. Following that, disconnect the alternator's 1P connector, severing its connection to the vehicle's electrical system temporarily. This disengagement is crucial for testing continuity without interference. Using a multimeter or suitable continuity testing tool, check for continuity between test points 1 and 2, specifically the tan wire from the alternator 1P connector to the body ground. This step helps to ascertain whether the LIN circuit shows continuity or if there is a potential short in the wiring that could prevent proper communication. If continuity exists, proceed to the next step. If not, it indicates a break or short in the LIN circuit requiring further examination. During this troubleshooting step, initiate a short circuit check by jumping the SCS, System Communication System, line using the HDS. This process will help to identify if there are any systemic communication issues within the LIN network. Continue to check for continuity between the terminal of the alternator 1P connector and the body ground. While doing so, one by one, disconnect the battery sensor 2P connector and the PCM connector B 49P to observe if continuity is lost upon disconnection. If continuity disappears, it indicates that the LIN bat sensor / LIN wire is functioning correctly, and you will then need to replace the part that triggered the disconnection. If continuity remains, there is a short in the LIN wire, and repairs need to be made accordingly to restore proper communication. For troubleshooting Step 5, begin by turning the ignition switch to the lock 0 position to ensure safety while working on the vehicle's wiring. Next, reconnect the alternator 1P connector to restore its connection to the system. After doing so, disconnect the battery sensor 2P connector for testing. You will then check for continuity between point 1, which is the blue wire at terminal 2 of the battery sensor connector, and point 2, which is the body ground. This will indicate if the battery sensor is still operational. If there is continuity, it suggests that the alternator might be faulty and requires replacement. If there is no continuity, proceed to the next troubleshooting step to investigate further problems along the LIN circuitry. In this 6th troubleshooting step, jump the SCS line with the HDS once again to facilitate communication for testing. Then, disconnect the previously mentioned connectors, the alternator 1P connector, the PCM connector B 49P, continuing to test the LIN communication pathway between these components. Check for continuity between the test points, which include the tan wire at terminal 16 of the PCM connector B and the tan wire at terminal 1 of the alternator 1P connector. If continuity is confirmed, it means the LIN wire itself is intact. At this point, make sure the PCM has the latest software updates. If it does not, you should update it. If issues persist, substituting a known good PCM could provide a definitive solution. If continuity does not exist, it indicates an open in the LIN wire, requiring necessary repairs. In this final troubleshooting step, jump the SCS line again, using the HDS to validate ongoing communication through the system. Subsequently, disconnect the same alternator 1P connector and PCM connector B, 49P, that were used in the previous tests. With the connectors disconnected, proceed to check for continuity between the test points. Specifically, the tan wire at terminal 16 of PCM connector B and the tan wire at terminal 1 of the alternator 1P connector. If continuity exists, this confirms the reliability of the LIN wire, leading to a recommendation for alternator replacement in case of earlier issues found. If continuity is lacking, it indicates an open in the LIN wire between the alternator and the PCM, necessitating thorough inspection and repairs according to the wiring guidelines before reconnecting everything. To complete the repair verification, turn the ignition switch to the lock 0 position to ensure safety. Reconnect all connectors that were previously disconnected throughout the troubleshooting process, ensuring they fit snugly and securely. Once all connectors are restored, turn the ignition switch back to the on-2 position. From here, utilize the HDS to reset the powertrain control module, PCM, so that it can recalibrate and recognize the restored connections. Additionally, execute the PCM idle learn procedure to optimize performance after the repair. Finally, check for any pending or confirmed DTCs with the HDS once more to ascertain the success of the repairs and to confirm that DTC P16E2 no longer appears in the system, indicating successful resolution of the communication error. For ongoing preventive maintenance related to DTC P16E2, it is vital to regularly inspect all connectors associated with the PGM-FI and ACG systems. Ensure that all electrical connections are secure and devoid of corrosion, which can lead to communication failures. Cleaning terminals and connectors periodically will help ensure optimal connectivity and reduce the risk of DTCs. It's also essential to keep the software for the powertrain control module, PCM, updated, as manufacturers often release updates that address communication issues and improve system performance. Maintaining these components will enhance the vehicle's overall reliability and ensure smoother functioning of the communication system, ultimately preventing future DTC occurrences. In summary, the DTC P16E2 signifies a communication failure between the PGM-FI and ACG systems, crucial for vehicle performance. Following the detailed troubleshooting steps outlined will help technicians accurately identify and resolve the issue. Each step builds on previous findings to ensure a systematic approach, minimizing the chances of oversight. Regular preventative maintenance can significantly reduce the likelihood of similar issues down the road, emphasizing the importance of checking connections and keeping software updated for the PCM. By adhering to these recommendations, vehicle owners can ensure a reliable running condition for their Honda CRV, enhancing both performance and longevity. Please like and subscribe to the channel. See you next time.